All right, so this is a very quick explanation of the features that we have to propose to the BAC, to the Foundation BAC to rank. And what we're going to do is we're going to spend about 2 minutes on each feature. Someone's going to introduce it for about 30 seconds, and then we'll all talk about it. And then when the time is up, I'm going to move us on. So even if you haven't finished discussion, we're going to keep this moving so that it's about half an hour. All right, so we are going to start with finalizing replacements of legacy constructs / functionality, and that goes to Richard to introduce.
Yeah, okay, so there are a few constructs that come from before provider times that are embedded in EVP key methods and EVPAs and 1P key methods. Mostly it's about controls that do some fairly advanced stuff where the back end hacks into some lib crypto structures. Those need to be replaced with something more provider friendly, or otherwise they simply will not work. And the other thing is that we need to clean up to be able to fetch algorithms by OID in CMS and PKCS7 and those sorts of features. Done.
So I guess the main objective here is readiness for 4.0, right? So we've already announced that 4.0 is going to happen in April 2026. And at that point, the plan is engines will disappear. And so if engines are going to disappear, we need to make sure that everything that relies on engines and those sorts of things we have replacements for.
All right.
Yes.
That sounds helpful. Next, Tomasz, we're going to talk about documenting or removing undocumented API functions.
So yeah, although we improved our API reference documentation when we were developing 3.0 release, and after that we documented more functions, there are still plenty of functions, more than 1,000, which are completely undocumented. So some of them might be even deprecated and later removed if they are not useful anymore. Some of these are already deprecated, I think, so perhaps those don't need to be documented, but at least those undeprecated, yes, need to be.
Yeah, I think I mean libSSL is almost there. There's a handful of functions which aren't documented there. It'd be fantastic if we could get that 100% documented. At least there's something there about every function, even if it's not fully complete. libcrypto, there's quite a lot of stuff which is missing.
Great. Moving on. We also are interested in more guide style documentation. And Matt, this is you.
Right. So we introduced several releases ago the guide style documentation, which is more how-to type stuff, taking you from knowing nothing to using the OpenSSL APIs. So we've already got some guides which introduce the libraries, introduce TLS, they introduce QUIC. They talk you through building specific code examples for TLS and QUIC clients and servers. And then they stop. There is so much more to OpenSSL. We could write a whole load more guides to introduce people who have never done this before. So we could expand into areas like CMS, for example, DTLS, X509. There's all of the EVP related stuff. So all the various different crypto operations, you know, for MACs or KDFs or symmetric crypto, whatever it happens to be, there could be different guides written for those. So this is just a generic. It would be great to expand the guide style documentation to more things. And I don't think we would achieve it all in one release, but it would be a sort of multi-release thing.
Yeah, the previous items, some of the previous items and following items are also like this. Like they are not just for one release, but for multiple releases. Yeah.
Yeah. And it seems like all of the things that are being added, there should be a guide to it, but that would be a ton of work. So, moving on, Tomasz, we have providers, fetching, decoders.
Oh, I think we've skipped over one.
Did I just
Yep.
skip? Oh, Matt. Yes, Matt. Additional PQC.
Right. So obviously the 3.5 release it's about to go, which already has MLChem, MLDSA, SLHDSA from the PQC side of things. But there's more to be done. So we have some TLS-based hybrid chem schemes. We don't yet have any hybrid signature schemes for TLS. You can do MLDSA, straight MLDSA, but you can't do hybrid MLDSA with something else. And that's because at the time that we were developing this, the standards weren't quite there. Hopefully by the time we get to the 3.6 release, they will be, or at least a lot further down the line. So that would be nice to have. There was some work done which never made it into 3.5 for some generic hybrid chem stuff where we have the framework and you can just kind of plug in the right algorithms and you get you get a hybrid chem. Similarly, you could do the same thing for signatures. Other stuff that's been proposed, there's the LMS and HSS signature schemes, which we don't currently support, but there's been some asks for that to be included. And then we've got other things like PQC and CMS. So there's a whole bunch of stuff, more PQC work that we could be doing.
All right. It sounds like
There's
Matt
not much
covered
to
it pretty well. So now let's talk about providers / fetching / decoders performance improvements.
Yeah, so we got plenty of like performance regression reports in the time of the 3.0 release, and we gradually worked on improving the performance through 3.1 release and subsequent releases. But there are still areas where this could be improved. It would, of course, require serious like investigation for where the main causes for the slowness are coming from. But we know that there are certainly areas around fetching algorithms from providers, loading the providers possibly, and especially the decoder framework could be improved with some like deeper changes in the how decoders are arranged and used.
So this is mostly about speed, not necessarily other factors like memory.
Mostly about speed. There are maybe some issues in memory consumption around maybe the decoders, because there are lots of like allocations going on. But yeah, the most critical thing is the speed, especially in multi-threaded applications.
Great. So Matt, let's talk about encrypted client hello.
Okay, so encrypted client hello. This is a TLS feature. So for those of you, I guess most people know, but in a TLS handshake, the first message that gets sent is the client hello, and it sends some basic client parameters to the server, and it's always up until now, it's always been unencrypted. Mostly that doesn't matter too much, but there are some things in there which could be sensitive. So, for example, the server name indication, i.e., the name of the host that you are connecting to, and also potentially things like the ALPN data, what protocol you're going to be negotiating. those things could be considered sensitive, and wouldn't it be great if we could encrypt those too? Well, there is a spec for doing this. It's been in development for some while. We have an external contributor, Stephen Farrell, who's done lots of work on this and has been slowly trying to get that code into mainline OpenSSL. It's suffered quite a lot because of all this other stuff that we've had going on. It's difficult to get review time, and there's a lot of code to review. So wouldn't it be great if it was a priority item that we can spend time on and allocate reviewer resources to, and make sure that this actually does get in a timely manner?
Yeah, I would like to emphasize this is like the most important thing is to get the review time, because we have the external developer who will be doing the development work. But maybe also we would do also some final cleanups, touches, I don't know, during the final steps of developing this.
Yeah, great. And then Matt, how about if we talk about some advanced QUIC features like zero RTT and path migration?
Sure. Okay. So obviously over the last several releases, starting with 3.2, we've been implementing QUIC code. So we've now got with 3.5 release, we've added the server side of stuff. So we've got your basic client and server QUIC functionality, but there's a whole bunch more stuff that we can be adding to that. So starting with zero RTT, obviously, so this is the early data stuff. TLS has support for early data. Our TLS stack supports that. As far as I'm aware, the other QUIC stacks also support this, and we don't yet because it was not sort of that was the next step really. So that would be great if we could add that feature. Something else which has been talked about quite a bit is registered mode polling. So we've got a very basic immediate mode polling. So we've got the SSL poll function. But if you've got, I don't know, thousands of SSL objects to poll, and you have to build them all up and send this list off to SSL poll every time, that's not necessarily very efficient. We would like to do a much more efficient polling mechanism through registered mode polling. Which will just improve performance, really. Other stuff we could be doing, there's a whole list of other things, but there's other extensions and so on that you can add to QUIC. So, for example, the unreliable datagram extension, which gives you a sort of a DTLS kind of equivalent in QUIC, so to speak. So, yeah, a whole bunch of stuff like that we could be adding.
Not much to add.
Yeah.
I think this is like for most probably for multiple releases.
Exactly, multiple release type stuff. We would have to work on this over a period of time, and perhaps just pick, I don't know, maybe registered mode polling or zero RTT as the next thing, and target that. Maybe two of them. I don't know.
Cool. All right, let's talk about our favorite issue: backlogs of GitHub issues and PRs. Tomasz.
Yeah, so we have more than 1,600 open issues. We have more than 200 open pull requests on GitHub. We have the oldest PR is older than 10 years, I think, and the oldest issue is older than 8 years, and that's only because we closed some issues for inactivity. So yeah, there are lots of issues and lots of pull requests, and we would like to somehow trim that backlog.
Yeah, and this is obviously an ongoing task, but I think over time, you can, if you look at the graphs, you can see it sort of inches up, all the time.
Yeah.
And wouldn't it be great if it was inching downwards?
Yeah.
And this is just the sort of thing where every software project has this, and the question is, are you consciously putting this as a priority, or are you just letting it grow? Because it will grow if you don't if you don't
Yeah.
sit down and say this is a priority for us.
Exactly.
I mean, the immediate priority, I think, is to try and stop the growth.
Yeah.
And then obviously removing, I think, decreasing the size would be the next step.
And some of these won't even require necessarily much more work than looking at and saying, oh, this is overtaken by events, or, you know.
Right. Some of them aren't always obvious what to do. Some of them are just, well, this is such an ancient thing, and we're never going to be able to work this out unless we get input from the original person, and they've wandered off. So let's just close it. Other things actually might require you to go and investigate it and see if you can figure out what the problem is.
Yeah.
And
The issues require various amounts of times, but some of
Yeah.
them, but at least some time you need to spend like at least like 1 minute on every issue, then you can count how long it would take.
Yeah. So the next item is BIGNUM refactoring for constant time. I'd love to hear about what that's all about.
So the BIGNUM library is like the basic building block for implementing the public key encryption for the RSA, DH, DSA, and elliptic curves that we have in OpenSSL. Of course, the new algorithms don't use this library anymore, but still elliptic curves and RSA definitely are going to stay with us for a long time. And this BIGNUM library has like serious deficiency in the sense that the length of the numbers that are represented inside the library are not constant, basically not fixed. So when you do the crypto operations, the length can vary during the operation, and unless there are extra steps done by the callers, they will basically leak the length in the sense of timing of the operation. So this project would refactor and redo the BIGNUM library in a way that the length will be preset at the beginning, and basically it would stay the same during the computations needed for this particular crypto operation.
Yeah, I think it's worth saying that this has been an issue that we've known about for quite a long time. I don't quite remember when it was first identified, but years. But it's never quite made it to the top of the priority list. OTC did actually vote recently to say, this should be a priority for us. So yeah, we would really like to spend some time on doing this one. But just to try and close it off because it's been open for such a long time.
Just a quick question, because I'm sure that, like Thomas said, that new algorithms don't actually use BIGNUMs anymore. So someone will probably ask, why don't we just let RSA die and declare everything connected to that, including BIGNUMs, legacy stuff that we can throw away soon?
But we can say that RSA will stay with us like for 10 years at least, I think. So it's like, it would be very bad if we just
I don't see RSA and ECDSA and DH going, certainly not in the short term. It's going to take years before they are no longer used again.
Cool.
Moving along.
That was a worthy question. Move along.
I agree. And so let's talk about increased test coverage, Matt.
Right. So we measure our test coverage at the moment. On the tip of master as of today, we've got 68.2% coverage, which is not at all great. This is really way too low from where we should be at. Between 3.4 and 3.5, we improved our coverage by 0.37%. So at that rate, it's going to take us another 16 years to get to the point where we achieve the okay-ish level of 80%. and that seems like a long time. It would be fantastic if we could put some concerted effort into this area and try and improve our coverage.
This will most likely, because many of our, or I would say even most of our test coverage is in form of like sort of integration or functionality testing. And we don't have that many unit testing, and unit testing would be like needed for raising the coverage seriously, especially in forms of negative testing, because negative testing is also very on low numbers.
Yeah, I suspect we could actually make some significant improvements if we look at the error handling code paths, in particular around sort of memory allocations and so on. So if we had some tooling support for injecting memory errors, memory allocation errors, then we could probably hit a lot of those error paths more easily.
We actually do have that tooling.
We have some things which are proposed. I think we could do much more in this area.
Tomasz, let's talk about the command line UI for attribute certificates.
So this is actually about some particular PR, which is already like opened. It needs more work. It needs reviews. It is about basically supporting, making the attribute certificates similar or covered similarly in functionality as the regular certificates are. So, yeah.
All right. Matt, what do you want to say about the QUIC stack performance improvements?
Okay, so yeah, so there's another quick one. Obviously, we're talking about the additional QUIC features that we could be adding, but this one is different. This is about improving performance. So far we've just been focused on getting the functionality and getting the core functionality, the core client and core server functionality in, not particularly focused so far on the performance. So we should probably spend some time looking at that. It's not just about measuring like the local performance, CPU performance and memory usage and that sort of thing, but it's also about how does the stack perform over the network. So this could be about tweaking our configuration parameters and our timeouts and things like that to ensure that when we're transmitting data, we're doing so in the most efficient way possible. And how does the stack perform, for example, where you've got, say, a high latency on the link, or maybe you've got lots of packet dropouts and, so poor quality network. How do we perform then? What kind of throughput are we getting? All of those sorts of questions. And the starting point is to start measuring things and understand how well we're performing at the moment, and then look for ways to improve. And again, this is likely to be a sort of an ongoing thing over multiple releases.
Yeah. This will require comparing us with other QUIC implementations and
Right. So we will need to know
and
what does good look like. Okay, so we measure it, and okay, you get a number. Is that good or is that bad? So let's go look at what other stacks are doing and compare ourselves.
And then DTLS 1.3. This is for Matt.
Sure. Okay. So obviously we already have TLS 1.3 support. We've had that for quite a long time now. But DTLS is still stuck on DTLS 1.2. The spec exists. And we actually have someone actively working on this. An external contributor has been working on this for quite a long time now. And again, this is about the review time required to look at this work that's being submitted and try and speed it up a little bit by providing some dedicated resource to reviewing this code and getting it in the code base. I would say that DTLS 1.3 is particularly important. Without it, there's no way of doing PQC at the moment in the DTLS world, because you need all the PQC stuff that we've got at the moment. For TLS is supported within TLS 1.3, and if you're in TLS 1.2, just no PQC support. So that means for DTLS currently no PQC support at all. So that's why we need DTLS 1.3, or one of the reasons we need it.
Sounds good. All right, Richard, it's your chance to talk about the simplified CLI idea.
Yeah, this is actually a thrown-in idea, but essentially, right now, our OpenSSL CLI is quite complex and have multiple commands that do the same thing in slightly various ways, and some of them are not as up to date with how the libraries work as others. So the feature set is very varying, and some are pretty legacy, and in my opinion should be thrown away simply. And every subcommand is developed as a program on its own, with its own option parsing and its own interpretation of certain options that are even also in other subcommands. We need to kind of unify all that to make it concise, comprehensive.
Right. I mean, the current CLI has grown up organically over since the beginning, so it's over 25 years old, and it keeps having bits added on here and there, and there's no coherent thought about the whole thing. And wouldn't it be great if we just looked at the whole big picture and said, right, okay, let's design a CLI that is simple, that as simple as it can be, but it achieves the goals. Wouldn't that be nice?
Also, the command line form of the options is not aligned with the current standards for command line applications. That's another area where we could improve. Yeah.
Great. Well, I think we've talked about all of the things we'd like to propose that the Foundation BAC rank. Obviously, this is potentially an incomplete list. If there's more that you all would like to add, that would be interesting too. But we wanted to make sure that we get some feedback on these particular features.